Okay, good evening. Lesson 11.2, continuing with areas. We're looking at areas of parallelograms and triangles. Um, you may already know how to find the area of a parallelogram and a triangle, but it is important that you understand how they are deduced. I would expect an honors geometry student to not only know what the area of a parallelogram is and how to calculate it, but how to deduce it or explain it to somebody. The same would be true for any triangle. Um, okay, so let's get busy and let's begin with that. First, we're going to look at the parallelogram. I've constructed a parallelogram here. This parallelogram is dynamic. I can drag it into a rectangle. I should also be able to drag it into a square or a rhombus. Not quite there yet, but you get the idea. We've studied these extensively. Looking at this parallelogram, we want to talk about how I would calculate the area. To think about area, just like with a lot of um, our deductions in geometry come with a clever auxiliary, and the same is true with the parallelogram. And that auxiliary is going to be the altitude. The altitude of the parallelogram is perpendicular, um, just as we have understood it to be in the altitudes to be perpendicular to the base. So that there is my clever auxiliary. And then I notice that I could, that creates a triangle there. That area is given in yellow. And that same triangle is over on the other side. Okay, so I could, if you can somehow visualize this triangle shifting itself down over to the other side. And I get this triangle here. So that area. Now let's consider those two areas. Those two areas are congruent. If I shifted this triangle over, they are congruent, but I can also show that they are congruent using some deduction as well. So again, I started with a parallelogram. I started with these being parallel and these here being parallel. So let's think about this a moment. Since I've got parallel lines, I've got corresponding angles congruent. So those angles are congruent. I also, it is a right triangle. We know that these hypotenuses are congruent. Let's see here. That's angle, angle, side. And so by angle, angle, side, we have congruent triangles. And we learned last lesson that congruent shapes have equal area. So those must have the same area. So if I cut this part off, I'm going to cut this triangle off and just place it over here. I'm just shifting the area of my parallelogram. What was part of my parallelogram on this side I've cut off, and now I'm placing on the other side to get a rectangle now. If you can ignore this little leg that I can't get off of there, I've got a rectangle. And that rectangle we understand to be the base multiplied by the height equals the area. So the area of the rectangle is equal base times height. And that every parallelogram is, with a scissors, you can turn it into a rectangle. So they are going to have the same formula for area. I'm going to erase that and kind of step through these again so that you can see them a little bit more rapidly. So those are my triangles. And we'll start again with my parallelogram. So I've got any given parallelogram whatsoever, any parallelogram. Drop an altitude, I see a triangle there. I'm going to take that triangle, cut it off, and put it on the other side. And I've got a rectangle. Every parallelogram can be done like that. So the area of a parallelogram, let me get my pen here. Area of a parallelogram equals the base times the height. Looking at our taxonomy here, we should be able to draw a few conclusions as well. Just as we had made some of these comments yesterday. So we're talking about the parallelogram here, and every rectangle is a parallelogram. We understand that to be base times height, and every rectangle is a parallelogram, so that will also work. We learned the square, also base times the height works for the square as well, but that's also the side squared, so we have a simpler equation for it. But we should be able to understand, using the taxonomy here, the relationships between all of the formulas for area. So as we progress through the chapter, we will start filling this out, and I think make some important connections about how shapes area is affected by the properties that they have. So here, again, every square is a rectangle, so and every rectangle is a parallelogram. So this parallelogram formula should be able to work for the rectangle and the square, as well as the rhombus, right? Because a rhombus is a parallelogram. All right, enough of that. Let's take a look now at triangles. We're going to follow a similar concept with a triangle there. Kind of gave that away a little bit. Here's a triangle. This triangle can be dynamic, should be dynamic. There it is. I can create any triangle I would like with that. It's dynamic. Now, a clever auxiliary makes this come into view, and that is creating a parallelogram out of it. This diagonal, basically if I have a parallelogram, the diagonal creates two congruent triangles. And in fact, we've already looked at that fairly extensively, but we can look at it again. If I've got a parallelogram, these are parallel, then without too much trouble, we should be able to prove that these angles here are congruent. And we should also be able to prove these angles here are congruent. Furthermore, these angles here are congruent. And by angle, well, that's not enough. Angle is not enough. There it is. We've got a reflexive there. So, angle, side angle, congruence. Allows me to see that both of those triangles are congruent. So, if two triangles, if triangle 1 and triangle 2 make up the entire parallelogram, if they make up the entire parallelogram, and these two triangles are the same, these two are the same, then to find the area of the triangle, I should be able to take the area of the parallelogram and divide it by 2, since two congruent triangles are formed out of the parallelogram. So what is that? Well, that's base times height divided by 2, which we often write base times height divided by 2, or 1/2 base times height. Area of a triangle is 1/2 base times height. Okay, so let me erase all of the scratch marks here. We'll clear this up, take that away, so we see our triangle. This is my base, and the height is the altitude. It's got to be perpendicular. That is my height. And so the area equals 1/2 the base times the height. Now, I'm going to use a different color to show you that my base doesn't have to be the bottom. This could very well be my base. Now, where is my height then? Well, my height would look something like this. If I extend this, I need to draw from this point here something perpendicular. This then would be my height, and this is my base. Okay, so that height is actually outside the triangle, that altitude. And I could look at it from one more direction. Let's pull another color up. We'll use orange. And here I'm going to let this be my base. So I'm going to let that be my base. Hopefully you can follow my colors here. Now what would be my altitude or height? I have to be starting from here, extending this over, and that would be my height. And area would be base times height divided by 2. So every triangle has 3 bases. Every triangle has 3 heights. You need to pair up the right base with the right height on any given problem. Let's take a look now at another look at the triangle one. Okay, so here I'm giving you that FB is parallel with AC. So these two lines are parallel. So when does this have the greatest area? When I let B slide. When does this triangle have the largest area? What do you think? Give you a second to think about that. Is it getting smaller in area now? Is it getting larger? Well, we can let Geometry Sketchpad do some work for us. And I'm going to calculate the area right there. Notice the area is not changing. Okay, was that your answer? That the area is not changing? You need to be able to see how the formulas behave and what is dynamic and what is static. Even though this triangle is in motion, its area is not. Why is it not? It's right here. AC, that is my base. So here's my base. This distance is my base. Where's my height? Well, my height is this distance here. Right now, that's my height. Or right now, that's my height. Or right now, that's my height. And what's happening? Is that height changing? It is not. That height is remaining constant. We see that B is held constant, H is held constant, therefore the area 1/2 base times height is being held constant. Okay? Now that. So another look at it here would be to look at those, all 3 of those triangles have the same area. Okay. All right. Let's take a look at a few examples real quick. Type of problems that you should be able to solve. Find the area of a parallelogram. Notice what is given and what is not given. Immediately when we say, okay, find the area of a parallelogram, area is going to equal base times height. So immediately we're hunting to find a base. Well, perhaps BD can be my base. Next I'm looking for my height. 6 is not my height. Now it's a common mistake students will make, is they'll take 10 and multiply by 6 and get 60 centimeters squared and be on their merry way, and it is incorrect. 6 is not a height. 6 is this side. What is the height? The height is this distance here. Perpendicular distance. So you need to use the other information in the sketch in order to find for that height. And hopefully you've seen it already that this is a 60 degrees. And this is a right triangle. It is a 30, 60, 90 right triangle, which we understand well. This is my hypotenuse. This is my short leg. This is my long leg. And if I know my hypotenuse, that means my short leg is 3 and my long leg is 3 root 3. And now I can. My base is 10 centimeters. Multiplied my height is 3 root 3 centimeters. That all gives me 30 root 3 centimeters squared. Notice the use of my units, and I've labeled my units correctly with centimeters squared. Be sure to do so. So you need to remember your nice right triangles because altitudes form that right angle. So you can expect in this chapter and in these problems to be applying that either Pythagorean theorem, Pythagorean triples, or families of right triangles that we have been studying. Now let's look at our final example. Find the area of a trapezoid. Now we haven't specifically talked about trapezoids and their area, but we don't need to because we're just going to be clever about how we divide this trapezoid up. So be clever about how to divide it up. I see here that I've got a large triangle with an altitude given. It would be nice to find the area of this triangle. And I can find the area of that triangle if I knew this base. So let's find that base. Well, it's a nice right triangle. As I mentioned before, hopefully you're spotting your nice triangles. This one is. This is a 15 divided by 3 is 5, 12 divided by 3 is 4. This is a nice 3, 4, 5 triangle. So now what is this actual base? Well, 5 times 3 is 15, 4 times 3 is 12, so 3 times 3 is 9. This is 9 units. So therefore this area is 1/2 times the base, which is 9, times the height, which is 12. Okay, that is 6 times 9, or 54 centimeters squared. Okay. All right, next, let's maybe subdivide and make another right triangle here. Is this a right triangle that we understand? Well, it would require me to know this base and this height, and I know that height. That height is 12 centimeters. It's the same one as that one over there, right? Same height. So, how did I know that? Well, because it's a trapezoid. So these are parallel. All right, so 12, 13. Ooh, this is what? Is it a 5, 12, 13? 5, 12, 13. So if that is 5, now I can find my area. 1/2 base times height, which is 30 centimeters squared. And now we're left with this rectangle in between. And we can find that guy easy enough. This is just going to be 5 times 12, which is 60 centimeters squared. And so my total, just like we learned last lesson, all I have to do is add up all of these parts. My total area is 30 centimeters squared plus 60 centimeters squared plus 54 centimeters squared. Add those up and we get, what do we get? 144 centimeters squared. Okay, So that would sum up tonight's lesson. Come prepared to practice parallelograms and triangles, but more than that, be able to explain, not just memorize their formulas, be able to explain them. All right? Good night and enjoy the remaining part of your weekend.